So let's look at some thermometric conversions. Look at the question here. So this one says the lower and upper fixed points of a resistance thermometer are 0.5 ohms and 3.5 ohms respectively. Remember, ohms is the unit of resistance, okay? So if it records 2.5 ohms in a certain environment, what is the temperature of the medium in Kelvin? So we are basically converting from ohms to Kelvin. Okay, so we're told that the lower and upper fixed points of the resistance thermometer are 0.5 and 3.5. So this is the lower fixed point and this is the upper fixed point. Alright, so this is the upper fixed point of our resistance thermometer, okay? And this is the lower fixed point, 0.5. Then we are given 2.5 ohms as a reading. It records 2.5 ohms in a certain environment. What is the temperature of the medium in Kelvin? So let's look at the Kelvin scale. This is the upper fixed point of Kelvin scale. That's basically the temperature at which water boils, okay? So this is 373 Kelvin and this is 273 Kelvin. Now this is how you go about it. It's very simple. You have this smaller interval here, this smaller interval, look at it, that smaller interval, over the larger interval, equals to the smaller interval over the larger interval. Let's get to it. So we have like I said, this smaller interval. So you find a difference here, this difference, all over this difference. So that's basically, you're saying 2.5 minus 0.5 on the ohm scale, all over this longer difference, which is basically the fundamental interval, okay? So that's 3.5 minus 0.5, okay? All of that equals to the same process here. So you do the same thing. This smaller interval, which is x minus this, x minus 273 on the Kelvin scale, all over the larger interval, okay? So that's 373 minus 273. So that's the formula. It's just interval over interval, and it works. All right, so this is what it looks like. So the smaller interval, 2.5 minus 0.5, all over the longer interval, 3.5 minus 0.5, equals to the same thing on the other scale you are looking for, which is the smaller interval. The smaller interval is x minus this, all over the longer interval, 373 minus 273. So you reduce it to look for x. So x minus 273, just cross multiply, 100 times 2, all over 3. So we have x minus 273 on the side. So if you punch your calculator, we're likely going to get 200 over 3 here. So our final answer is x equals to 273 plus 6.67. This is going to give us a 6.67. So move 273 here. So x equals to this plus 273. So our answer is 339.67 Kelvin. So just to recap, the smaller interval all over the longer interval equals to the smaller interval all over the longer interval on the other scale. Comparing any two scales at all, it works, whether it's from centigrade to Fahrenheit, Fahrenheit to Kelvin, Celsius to maybe resistance thermometer, whatever scale, this always works. All right, so that's it.